Hello everyone, can you hear me? Yes, thank you very much for your attendance. Music analysis is a field with rapid development, and I'm very glad to present you my work about music transcription of Chinese instrument, Pipa. So my name is Yuancheng Wang, the first author of paper. And our team come from Southeast University of China, and XiaoZhuang University in Nanjing, and Sorbonne University in France, Institute of Mines-Télécom Atlantique in Brest. So let's start with the introduction to Pipa and AMT. Then I will present you how we model Pipa recordings using multi-stream PLC models evaluated on our dataset. The models achieve a result immediately close to those of other instruments. Moreover, we show how PLC model locally work by visualizing the result of a snippet of music, as well as the result of vibrato and tremolo techniques. Finally, we look forward to the future of this kind of direction. For Pipa, it's a kind of plucked string instrument similar to the guitar, even though some archaeologists said they have the same origin, but they still have some differences. First, it has over 2,000 years of history. Second, in our study, we choose the modern Pipa, which is a pear-shaped, 4-stringed, 6-latched, 24 fretted. The most popular tuning method is a standard D, and it's used for open string. With the construction of Pipa, the pitch range and minimum research range can be easily defined. Third, Pipa is vertical played with fake nails on each finger like this. So let's watch the video. In first video, we will hear very clearly the vibrato and the tremolo effect. Second is a little bit complicated, a mid-level song on Pipa grade textbook. Slow down. Okay, very beautiful, isn't it? So our study is involved with ethnomusicology and non-Western music analysis, which is a hot topic. But the first challenge is the lack of dataset. Dataset creation for AMT requires expertise for notation. As a preliminary work to barely study the instrument, we first create a dataset and analyze its acoustic features. Then we explore the Pipa transcription by an interpretable model using these features. In this part, we give a quick introduction to the transcription task. Many definitions can be found in this overview. The simplified one aims to indicate the pitch, onset, and duration. Generally speaking, AMT could be seen as an audio-to-score task, including the other information like timing or playing techniques. In our study, the model only retains the piano roll like the A to C steps shown in the right picture. So PLC model is not a new technique but very highly interpretable. The main idea aims to factorize a polyphonic spectrum into a linear combination of monophonic ones. Given an input normalized amplitude spectrum V and the dictionary W, we resolve the A as the pitch activation matrix. So the pipeline of PLC consists of spectrum representation, the dictionary creation from the single note clips, pitch activation matrix extraction from polyphonic audio, and the post-processing converts the probability matrix into the final piano roll. Here we summarize the acoustic features that show how we model these features. So first, the same pitch may be played by different strings, and so we propose the multi-string PLC to deal with the timbres produced by different material and the thickness of strings. Second, we find the pitch deviation is an inherent property even though the open strings are well tuned. The pitch deviation distribution is shown in this picture. Third, two plain techniques of interest will be investigated. We group the pitch deviation and the vibrato into the pitch shift problem and model the knot envelope and tremolo technique with the attack decay state. And so first, the log frequency resolution spectrum using CQT and VQT allows to deal with the pitch shift with small range. As bandwidth decrease with the decrease of frequency, VQT smoothly decrease the Q vector towards the low frequency to get a more compact representation. In the left picture, you could find the time leakage before the onset is reduced by VQT spectrum. Now here is the three forms of decomposition. The first we only consider standard pitch from knot clips. In second, we introduce pitch shift, and the attack decay state Q is further added in third one. So in this part, a dataset consists of single note clips, polyphonic recordings of 9 famous pieces of Chinese folk music. The note level annotation is manually achieved through the waveform spectrogram and music notation. So there's some imperfection on our annotation. Equally, many metrics are proposed in music analysis field. Frame level evaluation is a basic one, but in some practical applications, the duration is not so concerned as the onset. So onset level evaluation is also important and used in our test. Except two aforementioned spectrum representation, we also tested the model on the clean ambience and the smartphone scenario, which is simulated by audio degradation toolbox. In right picture, we could find HMM version model has best global result, and in clean ambience, VQT version has have a better result, but in smartphone scenario, it's not always better on onset level results because of some annotation things, decay problem, noise, something like that. This right picture shows the local result from the snippet of song. Most arrows focus on banders. Some octave arrows. And some notation problem. Okay, so here we can find that this picture shows the spectrum distribution of A3 notes produced by different strings. We could find different amplitudes on harmonic series represented by log frequency spectrum like this, and a slight peak deviation for the partials corresponds to inharmonicity. Okay, in this part we recorded several notes with vibrato effects. This right picture shows the pitch spectrum obtained by ICPRS2021 model that contains the sawtooth-like pitch shift produced by vibrato techniques. And yes, you heard the speed up tremolo effects on note A4. Okay, we could find the results of HMM version model. The probability focus on the target pitch. Okay. So, in conclusion, we first created a dataset for Chinese traditional instrument Pipa and investigate the AMT task with a multi-stream PLCA to model its acoustic features. The HMM SIPLCA models achieves the best global result. The string distributions and two techniques of interest aims to further illustrate the PLCA models. So for the future, first the dataset took us 2 months to label. That is so tough. Currently, we are working on the dataset creation. Dataset which is satisfied with all these features. We utilize the signals from individual string captured by some sensors, which is much better than polyphonic notation. And second, another GUI platform is already implemented to help annotation in our future work. We will publish a dataset with all this technique. And second is to improve the performance from algorithm perspective. Okay, we'll try deep learning if we have a more massive data set. Finally, plain techniques analysis, particularly in polyphonic scenario, is very promising. And performance analysis effective computation can be benefit from this new descriptor. Here are some references for future work. Thank you very much for your attention. So, do you have any questions?